So welcome to this chapter in Advanced HTML and CSS, which is on animations, and we'll be looking into transforms. The transform property is a powerful tool to change the appearance of elements without affecting the natural document flow. You have likely seen it in action on many of your favorite websites. Transforms are very commonly used for animated effects. While we are sure you will like to create sleek animations of your own, we first need to understand how transforms work. Learning outcomes, how to use 2D transforms, how to use 3D transforms, how to chain multiple transforms, and the benefits of using the transform property. So we'll look into all of this. Basics of transforms. The transform property takes in one or more CSS transform functions as its values, with those functions taking in their own value, usually an angle or a number. Almost all elements can have the transform property applied to it, with the exception being call group, and non-replaced and line elements. Non-replaced simply refers to elements whose content is contained within the HTML document, like span, B and M, for example, as opposed to a replaced elements content being contained outside of the document, A, iframe, and img, for example. You do not need to memorize every element that is non-replaced, but rather keep this knowledge in mind should you try to apply the transform property to an element and aren't sure why it isn't working. So sometimes you might apply the transform property and it might not work, so you know. So it should come as a clue to you that probably it is a non-replaced inline element. Two-dimensional transforms. In this section, we'll go through 2D transforms with the following transform functions: rotate, scale, skew, and translate. Rotate. This is a transform function value to rotate an element on a 2D plane. So this is simple dot element class, transform, rotate, and inside rotate there will be some number or degrees. Below is a code pen that shows how the value affects the target element. Let's look at this code pen. So you have this original, rotate by 45 degrees. So rotate 45 degrees transform. So it rotates 45 degree clockwise. Rotate by -1 radian. So now it is anti-clockwise, -1 rad. And rotate 0.3 turn. So there is also something called a turn. One turn is the full 360 degrees, so 0.3 will be 108 degrees something. So let's see on a smaller size. So yeah, so these are the different elements. Scale. So these are the what can be the units. So it can be degrees, rad, radians, turn. Scale. These are the transform function values to scale an element on a 2D plane. Transform scale x, scale y, and just scale. Below is a code pen that shows how each value affects the target element. So scale x and scale y. So this is the original. Scale x 2.25. So only on the x dimension it gets squeezed. So it becomes 0.25 1/4. 1.5 dimension scale on the y dimension. So it gets stretched in the y direction. Scale by 0.25 and 1.5 on x and y dimension respectively. So it gets squeezed in the x direction and elongated on the y direction. 0.5 scale on both dimensions. So it is aspect ratio is maintained and it will become smaller. So it will become half on half. So it's become 1/4 in area. 1.5. This is the corresponding 0.5, 0.5. So this is the corresponding scale for 0.5, 1/4 of the original picture. Skew. These are the transform function values to skew an element on a 2D plane. Transform is skew x, skew y, and skew as a whole. Below is a code pen that shows this. So let's see an example. Original is a square. When you skew 45 degrees on the x-axis, so it goes left. So 45 degrees skews 45 degree. Left on left, right goes to the right. -0.5 radian skew on the y-axis, so this gets stretched on the y direction. Skew 45 and -0.5 radian on the x and y respectively. So you get a parallelogram kind of thing. Skew 45 degrees on x-axis, single value in function. So 45 degrees skew, if you have a single value, then it is x. If you have both the values, then it is x and y, both the x and y. Translate. These are the transform functions values to translate an element on a 2D plane. Translate x, translate y, and then translate. Below is a code pen. Check the code pen for translate x. So this is the original logo. Translate by 20px on the x-axis. So it goes to the right by 20px. Translate by -33% on the y-axis. So it goes -33%. So it goes up. So y up is negative, down is positive. Translate by 20px and -30% x and y axis respectively. So 20px it goes in the x direction, -33% it goes on the y direction. Chaining multiple transforms. Now that you have a grasp of 2D transforms, we will learn how to chain them. Chaining multiple transforms is as simple as adding more transform functions with a space between each one. Take a look at this code. So we have a red box and a blue box, two divs. Position is absolute, width height is fixed. We have the red box having a background rotate this and blue box background. There are two boxes located at the same position. We chain, rotate and translate function values in both boxes but in different orders. So first this is rotate and then there is a translate, and this is first translate and then there is a rotate. Make a guess of what happens to each box, then click the result link in the code pen below to see if you are right. So are you ready? So if it is red box, blue box, so first it is rotate and translate and then is translate and rotate. Let's check the result. So you can see they end up in two different places. So it is, if you guess correctly, congratulations, but it's a tricky concept. There is a bit of debate on how to read a chain of transform functions. According to MDN's transform docs, this is the MDN article, the transform functions are multiplied in order from left to right, meaning that the composite transforms are effectively applied in order from right to left. So this means that the red box, first it rotates and then translates 200%. So it translates 200%. Whereas the blue box, it first translates 200% and then rotates 45 degrees. So that's why they are in two different places, not at the same place. To learn more about the left to right or right to left interpretation, check out this visual article on chaining transforms. So this is a code pen. You can go through this chaining transform. While we can generally chain multiple transforms in any order for various results, there is one exception, perspective. This brings us nicely to the next section where perspective is involved. Three-dimensional transforms. The rotate, scale and translate transform function aren't limited to just the 2D plane. They work for the 3D plane as well. However, to perceive a 3D effect on some of these function values, perspective is required. From here on, the examples get more complicated, so there will be more links to external resources which do an excellent job describing how each property works. Play around with these properties until you feel comfortable with them, but be careful not to be too sidetracked with them. Perspective. This is the transform function value to set the distance from the user to the z equal to 0 plane. Element transform, there is a perspective. This is a perspective keyword. Essentially, by setting a perspective value, we are telling the object to render as if we are viewing it from a different distance on the z-axis. Unlike other transform function values, perspective must be declared first, leftmost, when there are multiple transform function values. In the upcoming examples, for example, rotate, scale, and translate, we will be able to see how it affects the target element. For more details on how perspective works in regards to 3D transforms, check out this CSS tricks article. So check out this article. Rotate. These are the additional transform function values to rotate an element on a 3D plane. Rotate X, rotate Y, rotate Z, and then there is a rotate 3D. Below is a code pen which shows how the first three values affect the target element. So we have a rotate X original, so X, it rotates on the X direction. Y will basically squeeze it in the X direction, and Z, which will be do the rotation on the XY plane. To learn how this rotate 3D works, check out this great demonstration on MDN and this one on Quackit. So there is a Quackit article as well. Scale. These are the additional transform function values to scale an element on a 3D plane. Transform scale Z, scale 3D. See MDN's 3D cube in action with scale Z here and scale 3D here. So scale Z and scale 3D, these are two nice articles that will make the concept clear of what scaling in the Z direction looks like. Translate. These are the additional transform function values to translate an element on a 3D plane. Translate Z and translate 3D. Translate Z doesn't do much without perspective. Instead, perspective and translate Z work together to create the illusion of three-dimensional distance from the rendered object as shown in the example below. So here we have this logo original. Once we translate 30px, it comes closer. Then we have translate of minus 100 px, it goes further. And translate minus 200 px, it goes furthermore. So translate with perspective will give you like the object is coming closer or going farther away. For a great demonstration on translate 3D, check out the MDN cube again. So MDN cube is a good article which will clear the concepts on perspective and these transformations. Matrix, while not strictly a 3D transform function, matrix is mentioned last in this lesson due to how uncommonly used it is. These are the transform function values for it. Matrix is used very uncommon, it's very uncommon, so transform matrix and matrix 3D. In brackets will have the element, will have the numbers. Matrix is a way of combining all the transform functions into one. It is seldom used due to its poor readability and almost never written by hand. Unless you have a very complex transformation to apply, you should use other transform function values instead. It is enough for you to know that these functions exist and generally how they work. However, it is not important for you to feel comfortable building with them. Skip this article. Article is on quackit.com to get the gist of matrix. So just have an idea, fair idea of what matrix is. Most probably it will be created by some program for you. You will not have to handwrite matrix numbers. Benefits of transforms. In order to understand why the transform property is great, you have to be aware of CSS triggers. You can learn about it in the pixel pipeline section from Google's Web Fundamentals. So this is the pixel pipeline. The key benefits of using transform is that it occurs during composition. This makes it cheaper to use compared to many other CSS properties. You can see a table of what triggers are executed with each CSS property here. This is a web archive, it's an article on csstriggers.com. Another benefit of transform is that it can be hardware accelerated via a device's GPU. You don't have to understand how a GPU works, but it is good to be aware of the term and what it means. This benefit is more prominent when it comes to transitions and animations, which you will learn about in the following lessons. Knowledge check. What are the four main functions of the transform property? So you know them now. Which function can be used to move an object through space on the X, Y, or Z axis? Which function can be used to make an object larger or smaller on the X, Y, or Z axis? Scale. What additional function is required for 3D transforms? Additional resources. Here's a good resource that summarizes most common transform functions with some additional insight to how you may use them. It is an article on joshwcomu.com. For a full reference, there's always MDN. For more on 3D transform function, W3 Schools has a good article demonstrating how they work, so you can refer to this article. With that, we'll come to the end of the first section in animations. Let's move on to the next one.